Greetings everybody. This video will hopefully explain how to complete on lab number 8. It's a momentum lab and it deals with two-dimensional collisions. Here's the template. Well, let me go ahead and first bring up the simulation. So yeah, here it is, collision lab. So we'll go ahead and click on it. And we're going to be doing Explore 2D and then Inelastic. So let me do Explore 2D first. And what the simulation is, this is an elastic collision. See, elasticity 100%. So it's an elastic collision. And what we're going to be doing, here are the instructions. We're gonna do the collision simulation for the elastic collision in 2D. That's this one here. And then we're going to do it for an inelastic collision in 2 dimensions. And in each case, so let's start with case 1. And our goal in case 1 is we want to calculate what I call theta 1 final and theta 2 final. As indicated in the figure here, theta 1 final, that's the angle that V1 final makes with the x-axis. Remember, V1 final is the final velocity of M1, which is the blue. V2 final is the final velocity of M2, which is the red. So we have here M1, M2. Then we have, a V1 final and a V2 final, and hence we have a theta 1 final and a theta 2 final. So that's our goal. Let me go ahead and bring up the simulation again. And so what we're going to do is we want to, I'm going to, up here in this box, we want to look at the momentum. The velocity, you can leave that on or off. It doesn't really matter. It's an elastic collision, so we don't care about the kinetic energy. Remember, for an elastic collision, the KE is conserved. And we want values, see? And then I like to look at the grid, okay? And then make sure, again, elasticity 100%, meaning it's a purely elastic collision. And then I like to click more data. And then here your speeds, you probably want to do slow. Now notice the default for the mass, initially it says M1 is 0.5 kilograms and M2 is 1.5 kilograms. Well, what we're going to do is we're going to run the 2D elastic collision for when M1 and M2 are, again, 0.5 and 1.5 respectively. Then we're going to do it when both masses are equal. Probably 2 kilograms is good. And then we're going to do it for the third trial when M1 is essentially twice as massive as M2. Where M1 is 3 kilograms and M2 is 1.5. And notice here I've got then the columns going from D over to N. Notice this is P1X final. In other words, that's the final X momentum of M1. This is the final Y momentum of M1. This is the magnitude of the final momentum of M1, P1 final. Likewise, for P2, this is the final X momentum of M2, final Y momentum of M2, magnitude of the final momentum of M2. Then here, this is theta 1 final. Again, look at the instructions. Theta 1 final. That's the angle that V1 final makes with the x-axis. Okay. And likewise, now we're going to do it using trigonometry in the x direction, and then we're going to calculate theta 1 final using trigonometry applied to the y direction. Then we're simply going to do a percent difference between those two values. Likewise, we're going to do the same thing for M2. Theta 2 final, again, look at the instructions. That's the angle that V2 final makes with respect to the x-axis. And again, we're going to obtain it using both the trigonometry as applied to the x direction and then trigonometry applied to the y direction. Again, percent difference between the two theta final values. And again, percent difference is very trivial. I've already entered the formula for you right there. Again, the percent difference is simply the difference between the two values divided by the average of the two values, because we're not doing a percent error because we don't really have an accepted value with which to compare. So we're just going to, but we know that whether we use trig in the x direction or trig in the y direction, they should yield, the value should be very close. We just do a percent difference. And you want to be within about 5% or less. Well, how does that work? Well, remember that basic trigs, I'll start with M1. Remember, we have M1 and M2. P1 x final, that's the final x momentum of M1. Well, P1 x final is just P1 final cosine theta 1 final. Well, that means that cosine theta 1 final is simply P1 x final over P1 f. Well, that means that theta 1 final is equal to the arc cosine of P1 xf over P1 f. Well, likewise for the y, P1 y final, in other words, and don't let the subscripts show you, that's simply the final y momentum of M1. Well, P1 y final is P1 final sine theta 1 final. Remember, x, the x component's cosine, y component sine. So again, sine theta 1 final is P1 yf over P1 f. That gives you theta 1 final is equal to inverse sine P1 yf over P1 f. So we're going to calculate, and again, they should give the same angle because the trig applies. And likewise, you're going to do the same thing for M2. Okay, so what we need to do is we need to enter the arc cosine and arc sine formulas into our spreadsheet. Okay, and that's what we mean. Well, actually, I'm getting ahead of myself. So what we're going to do, let me go back a step. But anyway, that's what we're doing. We want to calculate theta 1 final and theta 2 final. And with each one, you can use either the x, you can do it using the x direction or the y direction. And again, what are those angles? Right there in the figure. Okay, well, what does the simulation do? Good, we're good with time. All right, well, so now that's why with the simulation I have, notice here, M1, 0.5 kilograms, M2, 1.5. Now notice it sets, the default is it sets, M1 at the position -1, 0. It sets M2 at 0, 0.5. It gives M1 an initial Vx and an initial Vy. Likewise, for M2, it gives it a Vxi and a Vyi. And this is the initial x momentum of M1, initial y momentum of M1, initial x momentum of M2, initial y momentum of M2. Because remember, it's a 2D problem. So we have velocity, momentum, we don't need values, reflecting border, it doesn't really matter. Okay, then I've set the simulation speed to slow. And what happens is, I have all the initial values. Now what happens is, after they collide, it will give me the final velocities. It will give me, well, excuse me, the final momentums. Here you'll have P1x final, P1 final, P1y final, P1 final, P2x final, P2 final, P2y final, P2 final. The simulation will give me those final momenta. Okay? So, and if you notice in the spreadsheet, see P1x final, P1y final, P1 final, P1 final. Likewise, P2x final, P2y final, P2 final. So we're going to get these columns here. We're going to get them from the simulation. So let me go ahead and show you how that works. So again, all our ducks in a row. Now I do slow, and then I'm going to just hit play. Now when they collide, I'm going to pause it. We'll see now in the diagram, and again, the bluish, that sort of bluish color, that's M1, the red is M2. Oh yeah, see 1 and 2, that's M1, M2. Well, that 0.76 kilogram meters per second, that's P1 final. That's the magnitude of P1 final. Here over for M2, P right here, P is equal to 0.48 kilogram meter per second. That's P2 final. So let's go ahead and enter them in the spreadsheet. So P1 final, 0.76. Okay. P2 final was what? 0.48. You know, again, a little bit tedious, but it is what it is. Okay. Now, likewise, I now need P1x final, P1y final, P2x final, P2y final. Well, how do I get those? Well, let's look at the simulation. Here they are. Because remember, the chart after the collision, this more data section automatically updates itself. And we want to look right here on the far right. Here we have, notice the first row is M1, the second row is M2. So right here, where it's PX, this is the minus 0.67, that's P1X final. Right here, the minus 0.36, that's P1Y final. Right here, 0.42, that's P2X final. Right here, the minus 0.24, that's P2Y final. That's how I fill out the remainder of those values. So let me go ahead and pause it and put those in there. Okay, so what I've done in row 10, starting at the column D, notice I've got my P1X final, P1Y final, P1 final, which ended earlier, P2X final, P2Y final, P2 final. Okay, now I want to get theta 1 final and theta 2 final, but I want to get them using both the X information right here, column J, column M, and then using the Y information, column K, column N. So what is theta 1 final? Well, look at the instructions. We know that it's going to be the inverse cosine of P1X final over P1 final. So I need the inverse or arc cosine of P1X final over P1 final. Okay, well, so in Excel, you have to do this. I'm going to enter equals, and then it's going to be, we want to use degrees because the Excel default would be radians. So you enter degrees, and then you want parentheses. I like spaces and parentheses to make things easier to read. Then I'm doing the X first, I want the inverse cosine. Well, in Excel, it's A cosine, A-C-O-S. Okay, and now I want it to be, and I don't care about the negatives, because looking at the figure, because remember, we're using the reference angle. I want the angles with respect to the x-axis. So I don't want to fool around with them being negative. I know that theta 1 final is in Q3. I know that theta 2 final is in Q4. That's all I need to know. I don't need to worry about any negatives. So what I'm going to do is I'm going to enter, I want the inverse cosine, and remember, I want it to be P1XF over P1F. P1XF over P1F. But I don't want any negatives. So what I'm going to do, it's going to be the inverse cosine. I'm going to do parenthesis. Then I'm going to do an abs, meaning absolute value. Then another parenthesis. And then it's going to be P1XF, that's D10. So it's going to be D10. Notice D10 is highlighted. Then divided by P1F is F10. So it's going to be abs D10 over F10. See, and F10 is highlighted. Close the parentheses for the abs. Then close the parentheses for the inverse cosine. Then close the parentheses for degrees. Then hit check. And notice I got 28.1, and I already set the decimals to be 3. I got 28.167. Now remember, this is the beauty of Excel. We don't need to reinvent the wheel. I'm going to take this formula and I'm going to copy it. I want to do the same thing for theta 2f from the x. So I'm just going to do, let me click outside for a second. I'm going to copy this formula, and I'm going to paste it right here. And I just have to be careful to make sure that I update the cell references correctly. I'm going to do paste. Now, remember, for M2, it should be G10, because that's P2A. It should be G10. It should be the arc cosine of G10 over I10. And notice that's what it says. See, right here in the formula sheet, G10 over I10. And notice the angle happens to be 28.955. Now, the nice thing is, again, I can go ahead and copy that formula and paste it now to do the y. I can go ahead and do paste. Now, I'm going to have to go ahead and change cosine to sine. So, sin. And remember, it's the sine of P1YF over P1F. Remember, it's P1YF over P1F. Okay? So it's the arc sine of P1YF. So that's E10, which is correct, and then P1F is F10, not G10. So I have to take that G and change it to an F, because it's P1YF over the arc sine of P1YF over P1F. So it should be E10 over F10. And notice it gave me the degree. Notice the percent difference automatically updated. Now let me just go ahead and paste that formula here. Oh, I guess I got to copy it again. So let me go ahead. Let me copy this formula. Copy, paste it here, and then just double check the cell references. Okay, now for theta 2f from the y, it's going to be the arc sine of P2YF. It's going to be H10 over I10, which is correct. See, H10 over I10. And notice the percent difference automatically updated. Perfect. Now, we're almost done. Now what you're going to do is now set the masses here, M1 and M2, set them each equal to 2. So go back to the simulation, hit restart, right here, click here, and this chart comes up, 2.0, click here, 2.0. Okay, the masses are now I've got everything else I'm looking at. Then what I'm going to do, and remember now, right now, over here in this more data box where it says px and py, those are the initial momenta. In the spreadsheet, I only want the final, and the final won't appear until you run the simulation. Then you hit play. They collide, pause it at any time. And now right here, again, notice this table. Again, this is M1. First row is M1. So PX1 final is minus 1.09. P1Y final is minus 0.81. PX2 final is 2.09. PY2 final 0.41. So and you can enter those values. Then for P1 final and P2 final, remember those are given in the diagram. P1 final is 1.36 kilogram meters per second. P2 final is 2.13. Enter those in. Then remember with Excel, once you have the formulas entered correctly in your first row, all you have to do is remember when you click on the formula, just drag it down. Nothing shows up yet because they haven't entered the data, but do what we did. Repeat what I did for the 2 and the 2. Then set M1 equal to 3 and M2 equal to 1.5. And we'll reset and set M1 equal to 3. Enter M2 equal to 0.5. Okay, hit play, they collide, hit pause, and then you can enter in all your values. Alright, so that explains how to complete sheet 1. Let me go ahead and save this video. I don't want it to be too long, so I'm going to go ahead and get this video posted, and then I'll go on to sheet 2.